Hi everyone, in this video we'll look at how to find the vertex of f of x is equal to ax squared plus bx plus c. So sometimes when you are looking to find the vertex of a function and you don't want to go through the process of completing the square, you can either look to use partial factoring to figure out what the vertex is, or you can try to use either the quadratic formula, or even you can try to solve for the zeros by factoring. But sometimes you don't want to use any of those methods, and you might just want to figure out a way to determine what the vertex is just based on the coefficients of a, b, and c. Now, you might have noticed that when we're completing the square, it's kind of an algorithmic thing. So meaning that we're just following the same procedure over and over again, and there's patterns involved. So let's try to complete the square on this general standard form quadratic f of x is equal to ax squared plus bx plus c, and let's see what happens. Well, the first step is always to divide the quadratic term and the linear term by whatever this a coefficient is. So let's go ahead and we'll common factor that out. And if we do that, we get a times x squared plus b over a x plus c. Now the next step is to take half of whatever this term is, b over a, square it, and then add it and subtract it. Or take half of the coefficient on this x term, square it, add it, and subtract it. So if we do that, we can take half of b over a by doing b over 2a, where all that I've done is I've multiplied b over a by 1/2, and then I need to square that. And if I square that, I get b squared over 4a. Now, the next step in the procedure is to add this value and then subtract this value. So I've got a times x squared plus b over ax plus b squared over 4a minus b squared over 4a plus c. Now, these three terms make up a perfect square. So I've got a times, actually let's use square brackets as well. A times, and then I'll write this in red to show that I factored it. So x squared plus b over a, x plus b squared over 4a. Whoops, sorry guys, I missed another factor of a. This should be a squared, and this should be over 4a squared. And this should be over 4a squared as well. Sorry about that. So this red guy factors to, it's a perfect square trinomial, and it factors to x plus b over 2a squared. And then outside of the bracket, I've still got minus b squared over 4a squared. And then I'll close this square bracket, and then I've got plus c. So the last step is to distribute a into the square brackets to get rid of the square brackets. So I've got to distribute a to this term, and then I've got to distribute a to this term to get rid of the square brackets. So let's go ahead and do that. Well, if I distribute a to this first term, I just get a times x plus b over 2a squared. And then I've got a times b squared over 4a squared. So if I do a times negative, actually I should have negative b squared over 4a squared. Well, I can just divide out a factor of a, because I'll have a or negative ab squared over 4a squared. I can just divide out a factor of a. And so when I distribute a into the brackets, I get minus b squared over 4a plus c as my constant term. Now, why is this significant? Well, I've just completed a square on this generic trinomial. So this generic trinomial that has coefficients a, b, and c, and it's written in standard form. So what's the vertex here? Well, if I think about this, the x value of the vertex is negative b over 2a. Negative b over 2a. That's the x value of the vertex. The y value of the vertex is negative b squared over 4a plus c. Now, there's a little bit nicer way to write this, and it's just to change this to plus c minus b squared over 4a. So I can change this to plus c, plus c minus b squared over 4a. Now, this is my constant outside of the bracket, and that is the y value of the vertex. So I'm going to have the y value of my vertex is c minus b squared over 4a. And that's the y value of the vertex. So you can see that if you have a function written in standard form, if you want the x value of the vertex, you just do negative b over 2a. If you want the y value of the vertex, you can just compute c minus b squared over 4a. And that'll give you the coordinate of the vertex. So that way you don't have to go through completing the square, and you can just substitute into an expression. So that concludes this video, and we'll see you in the next lesson.